Mm, I think question is not proper. Okay, it could be maybe if with different PVT corners, why you need the extra other corners? Then you can mention that yeah to cover all the PVT and the RC corners. Okay. Now point two is important. How will you decide the macro channel? Okay. Channa, what will be your view?
Um, to decide the channel, yeah, we need to make sure there is no any logic or standard cells in between,
Why?
and uh,
Why we should not have any standard cell logic?
I mean between any two macros, there'll be no communication, like, right? If standard cells are placed in between, it might cause congestion and all.
Okay. First of all, understand one thing. Two macros will never be connected directly. Okay, one to one.
Okay,
This kind of connection will never be possible.
okay,
If one macro will be there, will be connected to standard cell, and that standard cell might be connected to macro.
okay.
Okay. Now, if you don't allow the standard cell in this region,
Mm.
then you will have zigzag like macro pin. It will connect this standard cell, and then again it will go to macro pin. Okay.
Okay,
So always macro channel will have the standard cells. Okay.
okay. When we did macro placement, there we made sure that the stand cells are placed only in the core region, right? Not in between
Yeah, because
macros.
our macro placement was wrong, Channa. Okay, we did only one iteration of the macro placement, right?
Mm.
Even I mentioned like macro pins are outside the die. I mean, outside die facing. Ideally, all the macro pins should be within the core only.
Okay.
Okay, anything else we need to take care?
Um, so
Okay,
you're saying,
Jamie.
Jignesh,
Ah,
in that square region, we are placing macros in the boundaries, right? Towards the boundaries. So standard cells were placing towards the core. Now, when you say we can standard cells should be there between two macros, then that placement will be scattered, right? Placement of standard cells in between macros.
it is not scattered. Let's say this is your block.
Mm.
You are placing the macros. This is macro one, macro two, macro three. Okay, so even if you standard cell are placing, let's say green are the standard cell,
Mm.
it is not scattered. Okay, because eventually standard cell need to connect the macro pin, right?
Yeah.
Okay, so that's how practically macro placement looks. Okay, always you should give the channel.
So why is this a condition that standard cells must be only placed in the core region?
There is no hard coded rule. Okay,
Center. Okay. So it's not like they should be only placed in here. They can be
yeah, it's not
placed
even you
anywhere.
can place macro also in the center. No problem at all.
Okay.
As far as IR drop, everything is clean. You can place macro also in the middle. Okay,
Okay.
fine. Any other factors from your side
Uh,
to consider?
we spacing width.
Okay, Jamie.
Okay. Okay, placing macros, right? What comes to mind is you have to placing macros is channel width, right? The pins of the macros, right, in between those channels, where are they? Are they connected to each other? Um, are all the pins kind of connected to each other? If not, you don't necessarily need a channel width. You can abort them, right? If they are not, if stuff needs to go in between the macros and from the macros that are not like connected to both sides of the macro, um you need to understand that and create channel width based on the metal tracks that will come in there. So you have like each pin, your number of pins for both sides, so you add that in, and your number of metal tracks. So from there, like your M wants how many metals you have available that will be used in that channel space. So from there, and your pitch. So from there, you can estimate how many macros, how much space you will need in the channel to pull it off. So I think that's really the secret here. You estimate your pitch,
Yeah, that
you
is right.
your
So one thing you can add here is it question is saying larger macros.
yeah,
Larger means you might have taller macro, right?
yeah,
So it will have more pins. So if it is taller, you should try to avoid this stacking, okay, vertical
yeah,
stacking.
yeah. You avoid
Okay.
vertical stacking. You also ensure that there is space for a power and ground route. You might
Correct.
also need some extra space because sometimes you may need to put something in between those macros as well. So those are some of the things you consider when.
Right. Like let's say reach to mem is there, okay. So you are getting code violation, reach to mem.
Mhm.
So we need to add the buffers to fix the
Yeah,
violation, right?
yeah,
So that's why we need to have some space available.
yeah. So those are the reasons why you get a channel width between memories or macros.
One more reason is there with respect to DRC, physical verification.
Yeah.
Do you
Uh,
know? Hmm.
DLC. Oh yeah. Shorts and opens.
No, not this way. See, as we are placing the standard cell in the channel, okay,
Mm-hmm.
it requires a tap cell placement, right?
Yeah.
So in the channel, we should have at least one column of the tap cells.
Yeah, yeah, yeah. Oh, I see. That's another one you need to put in there.
That is
Your
DRC
laptop.
perspective. IR perspective, you should have at least one VDD and one VSS within the channel.
Yeah, I talked about that. You need the
Correct.
power grid, a power ground
So
stuff in there.
basically, timing perspective, IR perspective, DRC
DRC
perspective,
perspective.
cell density perspective, all will be covered. Okay.
Yeah.
Okay,
Chandana, did
fine.
you
Yeah.
get it?
What, Jimmy?
Okay, never mind.
I didn't hear you.
Don't worry, it's not important.
Yeah, I am not able to clear this. I clicked on cleared my drawings, but I don't know. This is
Yeah,
that.
even I am also trying. Okay, it's not able to clear.
Yeah, no, it's
Yeah, now it's working. Okay.
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 Okay, scroll down. Let's see the answer. What is the answer written?
One column of capsules, some space for some long-list buffers, max strand buffers. You know, if there is no shared log, I'm guessing there is like stuff like pins and all. Should allow a large channel to allow all the shared logic that go into the gap.
Max trans buffers means for
Chandana, how do we fix max strand?
yeah, by breaking the long. Okay, now I got it. Those are the
Thank,
buffers for that purpose. Okay, to
thank
fix
you.
transition violation.
You can abort them if there is no need. That's what I'm saying. Like, if all the pins are just pretty much connected to each other or there's no need, you can just put them. Yep. And
Open up the gap further means we should increase the channel, right?
yep,
Between. Okay.
yep. If you have an overflow. Okay. Who's ready for
Yeah,
this
I
one?
think this we already discussed. Okay, Chanda, what will be your answer here? Question number 3.
Uh, so we need to place one strap of VDD and VSS in the channel between any two.
Okay, right answer. See, we are not pressing it. Okay, but we need to ensure at least one VDD VSS will be there. That should be the answer. Okay.
Who will
Right?
be placing it like?
Like it is placing through script only, correct? Power plan will be done through script. Okay.
Okay.
So if your power, let's say this is your VSS nets and this is the VDD net, red color. Now this blue color are the macro. So if you are placing the macro this way, right? So here in this channel, no VDD VSS. So you can fine tune the macro, okay, and you can adjust the macro because this power plan is created through script, right,
Mm.
uniformly over the whole design.
Mm.
So you can move this to macro a bit right side.
Yeah.
Okay, scroll down. Let's see the answer.
To check that there'll be check PG legality or something like that, right? To check.
No.
Okay. To ensure.
Yeah, I mean to check like whatever standard cells are there in the channel area, they are getting power or not. To check that thing, you can use the check PG connectivity.
Okay. So it's the same as checking. It's the same as checking if PG straps are in the channel, right? Same or different?
Yes.
Okay. So let's say there are no standard cells in the channel, then that command won't work to check the PG straps are
No.
placed.
See that command, right? Check PG connectivity, what it will check. All standard cells macro are getting power or not. In channel, if you don't have a standard cells, no
Hmm.
need of getting power, right? So it will not report any issue.
Okay. But by default, when we source the power planning script, every PG strap will be placed, right, uniformly.
Yes, right.
So it doesn't matter if we place standard cells or not, but
Yeah, it doesn't matter.
that
Right,
PG
right.
strap will anyhow be there. Okay.
Yes, correct.
That means
Okay.
by zooming to GUI only we can understand. If we don't use that command, there is no standard cell in the channel, but the PG strap is on the macros. They are not in the channel. Then we need to
Correct.
fine tune the macros, right? To check that we just need to
Yes, or you can
find.
write the script as well. Okay, you can write the script as well. Like you can get the macro channel, one macro, second macro. Within that channel, you will check whether any power is there or not. If no, that is problem. So this if you don't know script, you can do manually also. Okay, but yeah, our goal is at least one VDVSS should be present.
In the channel, okay. Script is only better, right, Jigish? Because if there are many macros, it will take a lot of time to check in the channel.
Yeah, but
Should-
for that, we should know the command. We should know the tickle syntax and all, right? So it will
Hmm.
also take some time. Okay,
Okay,
put
okay.
to put that algorithm into the scripting.
Yeah, right.
Okay, fine. Scroll down.
Sure time.
Yes, Jamie. This one, yeah, you try to tell the answer.
Okay, synthesis. The first thing that comes to my mind is logic depth. If there is huge logic depth, or even just the cell delays, um, because we don't really have much a good destination of like net delays so much. So I'm focusing more on the delays of the cell. I'm focusing more on what we give as our clock latency, our certainty, input delay, output delay. I'm checking that in the constraints as well. Those are the ways I will try to fix timing in synthesis.
Okay, let's say you are getting a rage to rage violation. How into rage input delay, output delay will affect?
No, into red, right? You said if I was getting into red or red to red.
Rage to rage you are getting.
No, because it never said into red or red to red, right? So I
Uh-huh.
just assumed it was everything. That's why I included constraint. So
Uh-huh.
that will not be applicable for red to red, but if it was anything involving into red, into out, or port to port, maybe that I can take a look at to see if anything can be done there.
Okay, right. So that we can do, which is to timing. What else we can do?
Um, what else? On grouping, possibly part groups. Those are things that I think I could do to fix it, to fix timing, give it more weightage. Um,
Even boundary optimization also will help. Okay,
yep,
because who will remove unnecessary buffers from the path?
yep. Boundary optimization. Okay, yeah, that too will help. Boundary, constant propagation, those kind of things. So yeah.
Okay,
Um,
scroll down. Let's see the answer. Okay.
Also, do I get to remove like register banking? Maybe that may help. That's a form of
But
ungrouping.
if you enable the multi-bit, right, then only you can remove registered banking, correct?
Yeah, yeah, that's what I think. Yeah,
Um, Okay,
add
path
group.
grouping we have discussed. Okay,
Yep.
fine.
Increase synthesis effort. Okay, yeah. Pipelining is possible. It's something I can discuss. But that's actually possible.
Yeah, that required the front-end feedback. Okay, we need to
Yeah,
provide feedback to the RTL team.
yeah. You need to definitely involve front end people. The banking multi-flop. It may or may not. It really depends. Set max fan out, max cap. Okay, yes, I definitely will check this in the constraints. Yeah, I thought about don't use cells, but a part of me, okay, yeah, don't use. Yeah, that's very important. Don't touch nets. I don't know if this one will be ready before synthesis. Maybe after synthesis, I'll have to check the tickle to see
Okay, so
why.
let's say one reason, right? Let's say in constraints, some command is there. Okay, don't touch and all.
Yeah,
Tool will
yeah.
not touch those nets. So let's say even though net is longer,
Mm-hmm.
tool cannot add the buffer on that net.
Okay.
So that could be one of the reason to get timing violation.
Yep. Yep. Don't touch properties. Yep. On cells as well. Also on group, I talked about grouping and ungrouping. Bounds, okay. I never said physical synthesis. Yeah, there's bounds as well. It's possible. Bounds magnet placement. I'm not sure what critical range would be, but register retiming is pretty much similar to pipeline stage. Okay. Of course, if it's a big flat module, that's going to be hard. Um, this one is more of DFT stuff.
This one is more important. Okay, n number splitting the global logic module like MBIST controller. So what will happen? Let's say your design will have few macros. Okay,
Mm-hmm.
so you are placing your macros, few macros here, few macros here, few macros here and here. Sometimes MBIST logic. Okay, MBIST is nothing but the logic to control your testing of the macro. Okay, macro built-in self test. Now let's say you have just one MBIST logic. So by default that logic will place in the middle. But instead that if you provide feedback to the RTR team, right? That split the MBIS logic. Okay. So they can split the MBIS logic, one logic connected to this macro, other logic connected to this macro. So your MBIS related timing path, right? That will improve.
Yeah. Yeah. Instead of everything just being in the middle. I see.
Yeah. Chandna,
It,
clear?
Yes, yes, Dignesh.
Oh, okay, good.
it's a form of like ungrouping, but it's probably just done on the RTL side.
Yeah, I mean this, yes, we need to replicate the copies, right? In the RTL and also area will increase, but yeah, this will reduce your longer distance.
Okay. 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 Ah. How do I know that you know, that this is good before we do PNR? Right.
Okay, let's check Chandna's view first. Okay.
So sanity checks can be done to check if it is good before
Right.
going.
Okay.
A particular command I'm not able to recall. Netlist related sanity check I have written from. Yeah. Check design.
Okay. What would you check in design?
So it will check if I mean it will check the quality of netlist. Like if there are any floating pins, I'm sorry, or multi-driven nets, black box module, undriven input ports, um, pin direction mismatches, unloaded output ports, unconstrained pins. These things it will check.
Okay. Okay.
So yeah,
Okay.
let's check. Try to check the answer. Scroll down.
We have check library. We have check timing. We'll check for probably linting issues. Some of the warnings in the synthesis, register replacements, those kind of things. Unique. Okay. Yep. Check timing. Check design. Yep.
Okay, now this one is clear. What is assign statement?
What is it? I see.
Oh, yeah.
I have explained in the blog. Okay, synthesis section.
Okay.
You want me to give it a go?
Sorry.
Should I try and give it a go while there shouldn't be an assigned statement?
Yes, yes. Yeah, try to answer.
Okay, so assigned statement kind of creates this is it buffers or so or something like that.
Yeah, to fix the assign statement, we may need to add the buffers. Okay,
Yeah, yeah.
but why assign statement are not expected?
Assign this is equals to this. It's kind of like a combinational stuff and all, but yeah, I'm not sure. I need to go
Okay.
refresh that.
So one thing is, see, if you have assign statement, right now understand why assign statement will come. You will have the modules. Okay,
Mm-hmm.
right? It's a module has one input pin, output pin.
Mm-hmm. Mm-hmm.
Okay. So input pin is, let's say, I1, output pin is O1, and
Mm-hmm.
input pin we have net connected I1.
Mm-hmm.
So if you see here, the basic rule is all the pin name, right? Module pin name should have exact same name as the net name. Okay. So net and pin, respective pin, both should have exact same name. So if you see here left side you have the C. Input pin is I1, net name is also I1.
Mm-hmm.
But if you check for this pin, output pin, net name is O1. But
Yeah,
your sorry, pin name is O1, but net name is the I1.
I want.
So that's
Oh,
why you have assign statement that assign
mm-hmm.
O1 equal to I1.
Yep.
Okay, so if you have assign statement,
Buffer.
when you are running the LVS, right, in physical verification, layout versus
Mm-hmm.
schematic, so at that time, some tool, right, some tool will give the errors if you assign statement.
Yeah.
Okay, it will give shorts.
Mm-hmm.
So
I
that's why we
see.
need to avoid the assign statement.
I see. Because of layout versus schematic issue. Okay.
Yes.
Yeah. Okay. Okay.
Now, netlist has to be unique. It may not be always.
Mm-hmm. Yeah.
Check timing, check design. Yes.
You guys are acceptable. Yep.
It will
Make
be
sure. Uh,
unique only, right, Jignesh, for any design. Different
yeah,
designs.
here unique means, let's say you have one cell is used, right? Now
Mm,
that cell cannot be used in other design. Okay, so cell name has to be unique. Okay, let's say we have two block A, block B.
mm,
Inside block A, whatever cell name is there,
mm.
that same cell name you can not use in the block B.
Okay.
So you can give the prefix of the module name or whatever. So that's
Yeah.
the unification.
Okay. Okay. Good. That one. Like how can we check? Using check design command only, or um,
So
like
manually, or you can check, okay, what are the cell name. So if
okay.
some prefix is given, that is good. Prefix
Okay.
is not given, it may create the issue.
Okay. Net
Okay,
list
then you
area
have, I
is too
think,
big. Yes.
yeah, basically PPA perspective, power performance area.
Yep.
Your floor plan area is less, but your net list area is more, right? It can also create problem.
Yep.
Basically utilization.
Yep.
That
All
means
right.
connection between any cells. Netlist area is nothing but connectivity between gates, right? So if that is very big, right? In that case, that is the case,
Yes.
or okay.
Area of standard cell and macros. Acceptable number of logic level.
Yeah, leg. I forgot this one. You need to do
Yeah,
leg.
LSC.
Leg and VCLP. I haven't even understand that VCLP so much, but yeah. Again, he asked this question. Not assign statement. This has to be unique. Check timing, check design.
Yeah, answer only copy pasted.
Yeah. What do you want to tell an RTL engineer if timing is not meeting? It's just constraints and logic depth. That's the only reason why I would go back to an RTL design person. Or maybe logic restructure.
But you are asking what you will tell to RTR engineer if timing is not meeting.
Yeah,
Simply we need to ask, right? Timing is not met.
I
Simple.
know. I know. We'll tell them. But yeah, they will usually say why. And you probably will have to say something like logic
Then
depth.
can we can also say, right, that have you checked your synthesis uh
Yeah.
QR?
Hmm.
Is it good or not?
Yeah.
Okay, fine. But yeah, I mean let's be proper answer. So yeah. For example, answer A is some timing exception, right? Scroll down. Because sometimes constant issue also can be possible, correct? If any path is multi-cycle path, but tool is not considering it. So tool will unnecessarily wasting some effort to fix the timing and all.
Yep.
Hmm. So that is required. That more rather we need to discuss with the constant team.
Yeah. Constraint in pipeline register, restructure of RTL. Optimizations we do in
Okay.
netlist.
Chanda, what is your view here? Question number 3.
Optimization. Uh, we can. One second. I'm not exactly sure, but there are three steps in optimization: architectural level optimization, logic level, and gate level optimization. Uh,
Okay.
so if it is like logic level optimization can be done, we can do that.
I really don't know. Okay, like from where this optimization is mentioned. This we have never discussed in our blog also.
Yeah.
Yeah, Jamie, what is your answer?
Um, it really depends. What are we trying to do? Um, you know, it depends on what we're trying to fix. Are we fixing timing? Are we fixing power? Are we fixing area? Um, We could enable more for area. We could do like register banking. We could do like constant propagation. So kind of removing all those cells that are having constant inputs and just kind of replace them with a buffer. We could do boundary optimization as well. Um, these are some of the things we could do to fix area. Um, yeah, so that maybe probably remove if we have enough slacks on some parts, remove buffers that may not necessarily be needed. That's another way to optimize on area and also power. So area and power are pretty much similar in a sense that you do that. For physical synthesis, another way you could save on power is you could move the clock data slightly further away from the sinks, but that depends on how much timing and how much margin you have on your timing part, because that could affect timing. For timing, you're looking at maybe optimizing transition, max fan out, max cap, also removing unnecessary cells or adding some cells to fix timing. Those are some of the things I feel you can do to fix timing in synthesis.
Okay, fine. Yeah, I think all these methods we have discussed.
Also, we can use
Uh,
don't use cells as well, but yeah,
fine. Okay, let's check the answer. Okay.
there's no
Oh,
answer.
answer is not there. Fine.
Yeah.
What exactly ungrouping does?
Okay. Anyone wants to go for this?
Ungrouping means it will basically match the subdesigns of a given level into one parent cell, one parent cell or one design. It will merge one all subdesigns into one design, by removing hierarchical boundaries. It will basically help in improving the area by sharing the logic.
Right. Yes. Okay, scroll down. Let's see the answer. Hmm.
Okay.
Okay, on low power, no need to understand more deep, but yeah, which kind of low power will be there, which kind of cells need to be added, where need to be added. So that thing you can revise. Okay. So there is one post on the low power thing. So you can that go through that post.
Yeah.
Okay.
So yeah, question 5 we have discussed. Scroll down.
Isolation cells.
Yeah, it is on more on the low power cells. Okay. So yeah,